domain. You might remember domain from back in freshman year. Domain is a list of all of the x values. If you remember, domain is x. Domain is all of the x values. The problem is that if we look at this graph, okay, let me return it back to normal. So that's what it looks like normally. If domain is all the x values, this line goes to negative infinity, and this line over here goes to positive infinity. I would take forever to write all the numbers that are included in this domain. So sometimes it's easier to write the domain on what numbers it can't be. Now remember, x can be a lot of numbers. But what are the only numbers that x cannot be? It can't be 0 because that makes your function invalid. So what numbers, what values of x make your denominator 0? Well, in this case, it's 1 and negative 1. So domain will be all real numbers except vertical asymptotes. Whatever those are. All numbers except vertical asymptotes. All real numbers except vertical asymptotes. So, we could find the domain. So the domain here, if we set the denominator, I'm only going to do one of these, but if we set the denominator equal to 0, so x squared plus 9x plus 20 equals to 0, we factor this. What multiplies to be 20 and adds to be 9? Well, you should have got 4 and 5. X plus 4 and x plus 5. So when we set them equal to 0, we get x equals negative 4 and x equals negative 5. So what that means is that the domain would be all real numbers except for negative 4 and negative 5, because those are the only numbers that would make the function invalid.